All right, hello Jaguars again. Okay, so today we are looking at lesson 16, and in our previous lesson we were looking at dividing one-digit numbers and having a remainder. But now we're looking at understanding and solving two-digit problems with remainders. Okay, now here on our notebook in our green folder, we're going to be working on just showing some different division strategies that we just learned. And we're going to move on to our blue math book, and we're going to do some practice problems in there. And then you will have some time to be independent and show me what you know based on your notes and what you've learned, okay? So let's get started. The first division strategy we learned yesterday was looking at an array. And if we have our division problem of 9 divided by 2, we know that we want to make groups of 2 from a total of 9 items. So, since we want to make groups of 2, we're just going to go down the line 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So out of 9, and when we divide them into groups of 2, we figure out how many groups we made where there's only 2. So we have 1, 2, 3, 4. So we have our quotient's going to be 4 because we have 4 whole groups of 2, but then we have 1 remainder. So our answer is going to be 4 remainder 1. And to check our work, we want to multiply our quotient, which is this 4. So we're going to go 4 times 2. Well, 4 times 2 is 4, 8. And we're going to add our remainder of 1. So 8 plus 1 equals 9. And since we're back at where we started, we know our answer is correct. Okay, now for our next strategies, we're going to be wanting to focus on learning something called the standard algorithm. Now, when we look at the standard algorithm, it's normally written, or division problems are normally written like this. A 9, or one, our whole group is written underneath kind of a half square, and our divisor is written on the outside. Now, what does this mean? We're still dividing, we're still going to go 9 divided by 2, but we want to make sure we know how to do our count bys till we get as close to 9 as possible without going past it. So, if we count by our 2's, how many times can I count up to 2 until I get to 9? Or at least without going past 9. So that's going to be 2, 4, 6, 8, 10. Well, I know 10 is greater than 9. So I can only go all the way up to 8. And I can do that by counting 2 4 times. 2, 4, 6, 8. So if I count it 4 times, 2 times 4 equals 8. And then we're going to subtract it. Okay, so 9 minus 8 equals 1. And then so we don't have any more numbers, so our remainder is going to be 1. So our answer is 4 remainder 1. Okay, and we can always check it by multiplying the quotient, which is 4 times 2. That equals 8. And then we add back our remainder, and we have 9. Now, what if we have a much larger number? Okay, if we have a much larger number than 9, let's say we have the number 63, and we want to divide that by 2. That's going to be a lot of dots to draw, okay, and then a lot of groups to count. And I'll show you what it looks like, and I'll let you know how long it takes for me to do all of this, okay? So I'm going to start a timer now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63. So for me, that doesn't take a lot of time because I'm used to it. That took me about 45 seconds to draw all those dots. But for someone who's done this for a long time, it makes sense that I can do it for a long time and do it quickly. Okay, but it takes a lot more effort to do that. Now we gotta count how many groups of 2 we had. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, and a remainder of 1. So that means our answer is 31 with a remainder of 1. But that took a long time. Okay? And then to check, we're going to do 31 times 2. 2 times 1 is 2. 2 times 3 is 6. Plus our remainder of 1. That's 63. But that took a while. Let's try it with the standard algorithm. So if we have 63 divided by 2, we're going to work on our first number, the 6, okay? Well, how many times can 2 go into 6 without going over? It'll be 2, 4, 6. Well, I landed exactly on 6 by multiplying 2 3 times. So I'll put the 3 there. Now 2 times 3 is 6. And it's important that you make sure you line up your numbers, your digits, okay? It is very important that you keep them on the same line. So then now, 6 minus 6 is 0. Now we can bring down this 3, okay? Because there's still 3 ones that are remaining that we need to take care of. Now, how many times can 2 go into 3? Well, if I count 2, 4, well, I already know 4 is higher than 3, so I can only count 2 one time. Okay, and 1 times 2 equals 2. And then now we can subtract. 3 minus 2 equals 1. So our answer is 31 remainder of 1, because there are no more numbers here to bring down. Okay, and same thing, we want to check our work. 31 times 2. 1 times 2 is 2. 3 times 2 is 6. We're going to add our remainder of 1, and we have 63. Okay? So these are the methods that you're going to be working on in your problem set. Now, let's go to our problem set and check out what we need to work on. If you need to pause to catch up or just to finish copying this down, go ahead and then make sure you press the play button once you're ready to go.